Bismillahirrahmanirrahim. I am Dr. Javed Ali, Assistant Professor, Department of Chemistry, Cust. Welcome to the course Physical Chemistry 2. Course code is 332. Today's topic is kinetics of third order reaction. Outline of the topic: Introduction to third order reaction kinetics, mathematical equation and data interpretation. Examples of third order reaction. In third order reaction, when reactants are same or the initial concentrations of reactants are same, the rate of reaction is proportional to exponent 3 of reactants concentrations. Third order reaction can be represented as 3A is going to product, where the concentration of all reactants are same. The rate law for third order reaction is dP divided by dt is equal to Ka cube, or minus dA divided by dt is equal to Ka cube. dP divided by dt represent rate of formation of product, and minus dA divided by dt represents rate of disappearance of reactant. So rate of change of product is equal to Ka cube, or rate of disappearance of reactant is equal to Ka cube. Rate of reaction is proportional to exponent 3 of the reactant's concentration. Minus dA divided by dt is equal to Ka cube, where A is concentration of reactant, T is time, and K is rate constant. Now we can rearrange this equation to convert into integrated form. So dA divided by dt is equal to Ka cube can be rearranged to d minus dA divided by A cube is equal to K dt by shifting A cube to this side and dA to another side. Now to convert this to integrated form, we can take integration of this equation. So the final equation is now minus integration dA divided by A cube is equal to integration K dt. Minus integration dA divided by A cube is equal to minus A power minus 3 plus 1 divided by minus 3 plus 1 by applying power integration rules, and K integration dt is equal to, and integration K dt is equal to K integration dt. Taking K out from integration symbols because K is rate constant. So minus A power minus 3 plus 1 divided by minus 3 plus 1 is equal to minus A power minus 2 divided by minus 2 is equal to K integration dt. By further solving, minus A power minus 2 divided by minus 2 is equal to 1 divided by 2 A power 2 is equal to Kt plus Z, where Z is integration constant. So now 1 divided by 2A square is equal to Kt plus Z, where Z is integration constant. The value of Z can be determined by value of A is equal to A naught at T0. By putting the value of A is equal to A naught at T0, we get 1 divided by 2a naught square is equal to z, because t0 kt is equal to 0 and a become a naught. So by putting the value of z in this equation, we get the final one. 1 divided by 2a naught square is equal to kt plus 1 divided by 2a naught square. So 1 divided by 2a naught square is value of z. We can rearrange the equation by multiplying 2 with both sides. Now we will get the equation 1 divided by a square is equal to 2kt plus 1 divided by a naught square. This is integrated form of third order equation when initial concentration of all reactants are same. So now this is straight line equation, and we can also plot this equation 1 divided by a square versus t. We will get a straight line equation with intercept 1 divided by a naught square and with slope 2k. We can further rearrange this equation by shifting 1 divided by a naught to another side. Now the final equation is 1 divided by a square minus 1 divided by a naught square is equal to 2kt. This is another form of third order equation when initial concentration of all reactants are same. We can also plot 1 divided by a square minus 1 divided by a naught square versus t. We will get a straight line equation with 2k and 0 intercept. We can further rearrange this equation by taking LCM of 1 divided by a square minus 1 divided by a naught square. So taking LCM of 1 divided by a square and 1 divided by a naught square, we get a naught square minus a square divided by a square a naught square is equal to 2kt. This is another form of third order reaction when initial concentration of reactant are same. So in same way, we can plot a naught square minus a square divided by a square and a naught square versus t. We will get a straight line equation with slope 2k and 0 intercept. Furthermore, we know that a is equal to a naught minus x, because a is concentration of reactant and a naught is initial concentration of reactant and x is concentration of product. So we can put the value of a as a naught minus x. So now the another form of third order reaction, by putting a is equal to a naught minus x, we will get the final equation a naught square minus a naught minus x whole square divided by a naught minus x square and a naught square is equal to 2kt. So we can also plot this equation. So we can also plot this term versus t, and we will get a straight line with slope 2k and 0 intercept. And similarly, we can further rearrange this equation to below form: a naught square minus a naught square plus x square minus 2a naught x divided by a naught minus x whole power 2 into a naught square is equal to 2kt. Further, we can rearrange to a naught square minus a naught square minus x square plus 2a naught x divided by a naught minus x whole square into a naught square is equal to 2kt. So we can cancel a naught square with a naught square. We will get 2a naught x minus x square divided by a naught minus x whole square into a naught square is equal to 2kt. Now in this equation we have a naught and x. A naught represent the initial concentration of reactant and x represent the concentration of product. So we can also represent the third order equation in this form, where we can determine the product concentration at any time. Further, we can arrange this equation into x into 2a naught minus x divided by a naught minus x whole square into a naught square is equal to 2kt. As we discussed earlier, that we can plot 1 divided by a square versus t, we will get a straight line equation with slope 2k and intercept 1 divided by a naught square. Similarly, we can plot a naught square minus a square divided by a square and a naught square versus t. We will get a straight line equation with 2k and 0 intercept. So by plotting 1 divided by a square versus t, if we get a straight line equation with constant slope, it means the reaction is following third order kinetics. Similarly, if we get a straight line equation of a naught square minus a square divided by a square into a naught square versus t and get a straight line equation with no intercept, this means the reaction is following third order kinetics. Half-life of third order reaction. First of all, what is half-life? Half-life is the concentration of reactant when it's reached to half of its original concentration. The time required is called half-life. So as we know that 1 divided by a square minus 1 divided by a naught square is equal to 2kt. This is equation of third order kinetics. So at half-life, where a is equal to 0.5 a naught, by putting the value of a at half-life, we get the following equation: 1 divided by 0.5 a naught square minus 1 divided by a naught square is equal to 2k half-life. We know that 0.5 square is equal to 0.25. So now the equation is 1 divided by 0.25 a naught square minus 1 divided by a naught square is equal to 2k half-life. Right. Now we can rearrange this equation: 1 divided by 0.25 a naught square minus 1 divided by a naught square is equal to 2k half-life to 4 divided by a naught square minus 1 divided by a naught square is equal to 2k half-life, because 1 divided by 0.25 is equal to 4. 4 divided by a naught square minus 1 divided by a naught square is equal to 3 divided by a naught square, which is equal to 2k half-life. By further rearranging, half-life is equal to 3 divided by 2k half-life square. This is a very important equation, where 3 is constant, 2 is constant, k is constant. So it means the half-life is inversely proportional to square of initial concentration. So by increasing initial concentration, the half-life will decrease, and by decreasing initial concentration, the half-life will increase. And the half-life is inversely proportional to the square of initial concentration. The half-life of third order reaction is inversely proportional to square of reactant initial concentration. Now, to calculate the half-life of reaction, if we know the K and A naught by using the half-life equation. For example, if we know the K is equal to 0.1 liter per mole whole square per second and A naught is equal to 2 mole per liter, then the half-life of reaction can be calculated by using this equation. So the half-life is equal to 3 divided by 2 into 0.1 liter per mole whole square per second into 2 moles per liter whole square. So where 0.1 is the rate constant and 2 is initial concentration of reaction, we get half-life is equal to 3 divided by 0.2 liter per mole whole square per second and 4 moles per liter whole square. Taking square of 2, we get 4, and 0.1 multiplied by 2 is 0.2. By further solving this equation, we get half-life is equal to 3 divided by 0.8 per second. Mole liter per mole whole square and moles per liter whole square will cancel with each other. By further solving this equation, we get half-life of reaction is equal to 3.75 seconds. So we can determine half-life of reaction if we know the initial concentration and rate constant of reactant. And similarly, we can also calculate the rate constant if we know the initial concentration and the half-life of reaction. Example of third order reaction. Below are some examples of third order reactions. Summary of today's lecture. The rate of third order reaction is proportional to exponent 3 of the reactant concentration. The rate constant unit is 1 over concentration square and time. So can be represented in liter per mole square per second if we represent the concentration in moles per liter. The half-life of third order reaction is inversely proportional to square of reactant's initial concentration. The integrated equations of third order reactions are given below. 1 divided by a square is equal to 1 divided by a naught square plus 2kt. And another form is a naught square minus a square divided by a square into a naught square is equal to 2kt. These both integrated equation or straight line equation. We can plot 1 over a square versus t. We will get a straight line equation with constant slope 2k and intercept 1 divided by a naught square. Similarly, we can plot a naught square minus a square divided by a square into a naught square versus t, and we will get a straight line equation with slope 2k and 0 intercept. These are some references for today's topic. And at the end, thank you very much.